In today's video, I'm going to explain the thermal decomposition. So, what is the thermal decomposition? Basically, the thermal decomposition is a chemical reaction that occurs to the reactant by exposing it to high temperature or heat in general and producing two resultants. Alright, two or three. So, let's say before the error, you have something called the reactants, and after the error, you've got the resultant. And above this arrow, you have the condition of the chemical reaction. Is it heat? So its symbol corresponds to it is the triangle, or is it diluted um, acid, or is it concentrated acid? So yeah, in our today's lesson, it's only the triangle because it's a thermal decomposition, something related to thermal energy. In thermal decomposition, chemical reaction, we're going to study the thermal decomposition of four things in this video. The first thing is called the oxides. The second thing is called the hydroxide. We also have got the carbonates and the sulfates. So what is the oxides? Basically, you have a metal attached to oxygen, all right? And for hydroxide, you have got a metal attached to the hydroxide group. For carbonate, you have a metal attached to the CO3 or the carbonate group. And for sulfate, you have a metal attached to the SO3 group or the sulfate atomic group. So we're going to study each one separately. So the first one we have is called the oxide. So the chemical reaction for the thermal decomposition of metal oxides um, is basically like that. You have the reactant here exposed to heat or a high temperature gives you two resultants. Let's say here you have a metal oxide, right? So by exposing it to heat, you just destroy the bond between the metal and the oxygen. So the first resultant is the metal that is in the reactant, and for the next or the other resultant is the oxygen. So let's have an example on that. So for the metal oxide, let's say we have the HgO or the mercuric oxide. So we're gonna expose it to high temperature or heat. It gives us two resultants. As we said, the first resultant is the metal, and the metal here is the Hg or the mercury. So it's Hg. And for the other resultant, it's oxygen, this one. So we're going to put it as O2. So why did I say O2 and not only O? So there are nonmetals that can exist separately in the normal state. And those nonmetals are the halogens, which are the fluorine, chlorine, bromine, iodine, and some other nonmetals like oxygen, nitrogen, and hydrogen. So in this case, it's O2. So before I skip to the next part, just you just need to know that you have to balance this equation. So before the arrow or the reactants, you have got one atom of mercury. In the resultant, you have one atom of mercury. So moving to the oxygen. In the reactant, you have one atom of oxygen but in the resultant you have two atoms of oxygen. So you have to make them equivalent. So for the reactants, we're going to put 2 here. So it's multiplied by O. So it's 2O in the reactant and 2O in the resultant. And you also have to put 2 here. So it's 2 mercury for resultant and 2 mercury atoms for the reactants. All right. So now let's see this other example also on decomposing the oxides or the metal oxides. We have magnesium oxide. By exposing it to heat, you get two resultants. The first one is the metal, and the metal here is the magnesium, so it's Mg. And here the oxygen, and it's in the diatomic state. You have to balance this equation, so it's 2 here and 2 here. And that is the full chemical reaction for decomposing the metal oxide. Just before I skip to the next part, you have to also to know the colors of these. So the mercury oxide exists in the red color, and here mercury is a silver color. Its color is silver, like the mercury, you know it. And here it exists in the red color. What about the next one, which is the hydroxide? So here in its name it says hydro, right? So it has something related to water, okay? So basically the chemical reaction goes as following. You have got the metal hydroxide here, expose it to heat, and you get two resultants, also two resultants. The first one is the metal oxide, and the other one is H2O or water vapor. So you know in hydroxide, the resultants has something related to hydro or water, which is H2O, and you also have here oxides. So let's have an example on this. So we have the copper hydroxide, and by exposing it to high temperature, you get two things. The first thing, as we said, is the metal oxide. So the metal here is copper, right? So you put copper, and the oxide is attaching an oxygen atom to it. So it's CuO, copper oxide. And since we said we are decomposing the something hydroxide, so it has something related to hydro or water in the resultant. So here we're going to put H2O or water vapor. And here we don't need to have any to balance the equation. One copper atom, 2O, 2O, and 2H. It's here. And for the color, just remember that here the copper hydroxide, as we said, hydro is something that has water inside it. So as you know, the C color is blue. So this one is blue color. And the copper oxide is a black color. What if you want to decompose this copper oxide by, by exposing it to a heat source? So this is copper oxide, right? So we get two things. The first one is the metal, which is copper. And the second resultant is the oxygen. For the third thermal decomposition reaction is the carbonate. So basically, you have the metal carbonate here, you decompose it, and you get two resultants. Just like the hydroxide. The first one, you get the metal oxide, and the second one, you get the carbon dioxide. So this has carbon Just remember that there is a carbon dioxide in the resultant. So let's have an example. Let's say we have copper carbonate. By exposing it to heat, you get two resultants. The first resultant is the metal oxide. So where's the metal here in the reactant? It's the copper, right? Not the CO3 or the carbonate group. So CO3 and attach an oxygen atom to it. So it becomes oxide. So it's copper oxide, right? And since we said this one is copper carbonate, so it has the carbonate group or the carbon atom. So we are going to put here for the other resultant the carbon dioxide or CO2. And just know that the copper carbonate has a green color, and as we said earlier, the copper oxide has a black color. Now let's see the last thermal decomposition reaction, which is the sulfate, the metal sulfate. So basically you have a metal sulfate, you expose it to heat, you also get two resultants from this decomposition reaction, just like the hydroxide and the carbonate group. You get the metal oxide, and here you just put the sulfur trioxide. So let's have an example on that. Let's say we have copper sulfate, right? And you decompose it by exposing it to heat. You get two resultants. The first one, we said it's metal oxide. So the metal in this reactant is the copper. So you put copper, and to become oxide, you attach it to an oxygen atom, right? And for the other resultant, its constant is SO3 or sulfur trioxide. And the color for copper sulfate is the blue color. And the color of copper oxide, we said it's black color. So this is just a quick note how to detect CO2. So as we said, when we decompose the carbonate or the metal carbonate thermally, so let's say we have the copper carbonate thermally becomes copper oxide plus CO2. So how to detect that this gas is CO2? You basically just put this gas into something called lime water, and it just turbines this lime water. It becomes turbided and not that clear. And this is how you can detect the carbon dioxide.